Okay, let's represent time using a velocity versus time graph. Okay, so remember step one, we're looking at our axis. It's velocity on the y-axis and then time on the x-axis. Runner runs forward at 4 meters per second for 20 seconds. So they went a total of 80 meters. How do we know that it went a total of 80 meters? Remember, velocity equals distance over time. And, well, delta x over delta t, if I'm not rushing and doing it properly. Delta x over delta t, right? And if we want to find the displacement, we're going to multiply each side by delta t, and we get velocity times time gives us our delta v. So if we took the same time interval from 20 to 0, so 20 seconds, and we multiplied it by our velocity is not changing, so this little trick works here. It's uniform. Uniform means the same. So then it is 4 times 20. Pretty cool, right? Well, actually, what we just did is we took this little graph and we turned it into a rectangle. And we found the area under that curve of the graph. Even though it's a straight line, we still call it a curve. So what we did is we found the area under the curve. So the area under the curve for a velocity versus time graph is our displacement. And that's going to be true if the next piece is a triangle. If it is, then we're just going to find the area for this here, and we can figure out the entire displacement. That is the gist of this one. If you need to skip ahead or something, that's fine. If you want to stay tuned to get the details, then come on. Alright, stops for 10 seconds. So notice this big gap here. You don't have to connect these lines. It's just a gap. There is no downward. If you put a line here, then that kind of means at this exact instant it went straight down. Jogs backwards for 2 meters per second. So here we go. That means it's going backwards for 60 meters. But I just told you to find the area under the curve, right? To find the displacement for this time from 60 to 30. Well, you know we're going to turn it into a shape that we know the area formula for, which I don't know how your area formulas are in your brains, but mine are pretty simplistic. I know rectangles, squares, and triangles. And I'm going to cut everything down into one of those. So we're going to find the area under the curve. Area under the curve. So that under does not necessarily mean it's under, because look at what we've done. We have gone from the curve, which is here, up towards the x-axis. So it's everything above the curve when we're in opposite world. Opposite world happens below the x-axis. It's where we get our negative numbers, like right in here. So area under the curve is displacement for a velocity and time graph. Then we stop for 20 seconds, then we walk forward for 20 seconds. This means we're going forward 20 meters. Whoa. Oh, sorry. There we go. Each segment takes place with constant velocity, so each segment of motion is a straight line. We can connect the horizontal segments by vertical lines, if we like. Moving forward is positive velocity, so these lines are above 0. Backward is represented by lines below 0. Lines that are represented by flat lines are 0. That means our velocity is not changing. Whenever there's a flat horizontal line, our velocity does not change for that time period. That doesn't mean we're stopped. That just means our velocity is not changing. Our velocity is constant. The faster the object goes, the farther the graph is from 0. Runs forward at 4 meters per second for 20 seconds. That means it's going to go forward for 80 meters, right? Because we did that area under the curve. Notice that 80 is also the area of the rectangle of the velocity, the graph corresponding. This is because the area of velocity versus time graph is displacement. Say it out loud. The area of velocity versus time graph is displacement. How far the object travels during that part of the motion. Backwards, so here we go, we're going to find the area under the curve. Notice that 60 is the area of the rectangle on the velocity, corresponding to moving 2 meters per second for 30 seconds. The area is negative because the rectangle is below the horizontal axis. That's important too. The area is negative, so we have a negative displacement. That means we're moving closer, or we're going back towards the origin if we were moving away. We're moving left. This is because the area of velocity versus time graph is displacement. How far the object travels during that part of motion. Walks forward at 1 meter per second for 20 seconds, and then the area of velocity versus time graph is displacement. And that's it for now. We're going to come back and we're going to go through those, test your understandings. What I would recommend doing right now is try them for yourself.